Guys, I want to try something a little different. In the previous lesson, we've been speaking about things, and I want to show you a little clip that I recorded before, and I want to see if it works. So this is going to be about a minute, and then I'm going to ask you what you think you saw in the clip or what you understood. So let's just see if I can get that to work. So it's going to go, and I'm going to play it at 2 times speed. And I want you to look at it and see if you can realize what I'm trying to show you. Okay, I'm just going to pause there for a second. What do you think I was trying to show you in that little clip there? So I want you to put in the chat, what do you think the point of this little drawing was? And I'm interested to see what you guys think. Anything, what do you think I was trying to show you? Similar triangles? You betcha. And what about the similar triangles? Okay, so I was definitely trying to show you the similar triangles, but more than that. So I started off, the one was an equilateral triangle with lengths 1, 1, 1, and the other one was an equilateral triangle with lengths 2, 2, 2. And you're quite right, they're similar triangles. But not just that, if I cut one of them in half, I got another triangle, and that triangle had a 90, a 60, and a 30. And why do you think I cut? If I was going to do trigonometry, why do you think I had to cut the equilateral triangle in half? Remember, the topic is trigonometry. So why did I cut these equilateral triangles in half? Okay.
I think Lebohang might have the answer for us.
Lebohang,
what do you think?
Go ahead. Okay, so
don't forget to unmute.
That's all right. So the point was, you need a hypotenuse. You also need a 90-degree angle. So what I did was I made a right-angled triangle out of my equilateral triangle by cutting it in half. And when I cut one in half, I got a half. And when I cut 2 in half, I just got 1. So I just want to point out that both of these triangles, the 30, 60, 90 triangles, they're similar to each other, but they do both have a 90-degree angle. And then I showed you that the cos of 60 was still the same, even though the triangles were a different size. And so that's a really important idea, because in the first 2 questions today, when we revised the last lesson, we are going to use these, I call them internal scale factors. So if you type the cos of 60 in your calculator, do that right now. What do you get if you type the cos of 60 in your calculator? Forget about me drawings here. Just type the cos of 60. And then I want you to put it, okay. So you'll notice that your calculator knows what the value of the cos of 60 is. And what the cos of 60 is, it's just basically in fact, let me just draw a little triangle below here. So if I take, remember this was 2, this was 1, and this one we don't know what it is. If we look at this 60 here, in terms of trigonometry, we call this the H, we call this the O, and we call this the A. And what I want to point out is that the cos of 60 is just the length of the A, which is 1, over the length of the H, which is 2. And once we know what that is, we can use it to solve problems. Now, I'm not sure if all of you will get exactly why I'm doing that, but I want to now go to a question where we use these internal scale factors. So let me go to this. So you are given two triangles like this, and you need to find the missing side. The missing side in this one is x, it's the hypotenuse. The missing side here is something else. I want you to see, can you solve for x? And in doing so, you're going to have to use your calculator's knowledge of an internal scale factor, or a trig ratio is another way of saying it. So can you try and solve this? This is just a little bit of revision from the previous lesson. And then once you've done it, if you could put that in the chat, please. David, do we use cos? That's a good question. How would we know if we should use cos or sine? I think we need to label things. So why don't we label them? I think this always is H. Now the 72 is down here, so I think that has to be O, and then that one has to be A. So how can that help us? And then this next one, this is going to be O, H, and A. Okay, so I see some answers coming in for the first one. Let's also do the second one. So if we want the X, I suppose we should kind of go, we know we've got an A and we've got an H. What trig ratio? So we use this thing called SOH CAH TOA. And so what involves A and H? It's going to be cos. And so we're going to say the cos of 72 is equal to A, which is 6, over H, which is X. But now we have a problem because the X is at the bottom. And so we need to do some algebra where we multiply both sides by X. If we multiply both sides by X, we can get X times the cos of 72 equals 6. And then if we divide both sides by the cos of 72, sorry guys, we should get that. And so now we have 6 divided by the cos of 72, and we should get 19.41. Or 19.42 rather. And that's going to be the length. Or 19.4 if I'm rounding off to 1. Sorry, it says to the nearest 10th. So it should be 19.4. So what I want to point out is that in this question, I haven't actually worked out what this number is, but cos of 72 was that special value that your calculator knew that we could use. Okay, now can we use a similar idea to find out what the answer to question 2 is? So luckily, in this one, we're going to say we know it deals with A and H because those are the two. We've got the information for 6 over here, and we've got the information for X, that's A and H. What trig ratio deals with A and H? It's cos. So I'm going to write the cos of 73. And the cos of 73 should be equal to X over 6. Luckily now the X is on top. And so when I multiply both sides by 6 now, I get 6 times the cos of 73 equals x, because basically the 6's on both sides are getting cancelled out. And my final answer should be 6 times the cos of 73, which gives us 1.754, which if you round up to 1/10, it's just going to be 1.8. Okay, so this is what in grade 10, we call solving for unknown sides. And really what we do is we just use SOH CAH TOA. And that's what we did at the end of the last lesson. So if this is your first lesson and you feel a bit unsure of this, I would say look at the end of the last lesson where we did this. But I want to point something out. In question 1, we used the cos of 72. In the next question, we used the cos of 73. And then the first example of the day, we used the cos of 60. And I want you to just check on your calculators. What are those values? Just type in the cos of 72, see what you get. Type in the cos of 73, and then just have a look and see what you get. And then won't you type it in the chat for me? What do you get for cos 72 equals? And then cos 73, what do you get for that? There's only a slight difference between the two. What I want to point out, guys, is that the numbers change. So if you use the cos of 60, we got a half. But at cos of 72, we get about 0. The values are changing over time because the size of the triangles is changing, but the method will stay the same. Okay, maybe I'm going a little bit too much detail with this. So let's move on from that first one. And let's just do this last bit of revision. In this, you are given 2 sides and you have to find the missing angle. I want you to find the missing angle over here. So start by labeling. So this would be O, that would be O. And then I want you to find the missing angle in each of these 2. And there's a slightly different process you have to follow. Okay. Coco, anything from is there a hand up I see there?
Yes, I see Kwakanya's hand is up. Would you like to ask the question, sir? Don't forget to unmute. Oh, he's typing in the chat. I'll let you know just once. Oh, there he is. Hi,
hello.
Hello. Hello.
Hi, as you know, my name is Wakanya. I'm sorry, I am new to this and I'm confused.
Okay, so this is the 3rd lesson in our series. What we're doing, the topic is trigonometry, and we basically are just looking at how to find unknown angles and unknown sides. So we're revising some of the stuff from grade 10, and then later in the lesson, we're going to get to something called reduction formula. What I would suggest is if you're feeling a little bit overwhelmed today, have a look at the previous videos because they will sort of get you up to scratch in this particular topic. Okay, let's have a look at this one over here. If I've got O and A, we know the trig ratio that's involved is tan. And so tan of something, I'm just going to say the tan of X, and that is equal to 27 over 38. Now, what's different about this bit is we need to use what's called the inverse trig ratio. Again, I spoke about this in the previous lesson, and we type in our calculators shift tan, and then we type 27 divided by 38, and we should get the answer 35.39 degrees. And that's that angle over there. And then for number 10, what we're going to get is it again involves O and A, but in this case, it's going to be the tan of, let's just say the tan of Y equals O, so 9 over 21. And then to find out what Y is, we go shift tan 9 divided by 21, and we should get 23.1, actually it's going to be 23.2198, so it's going to round up. And so this is finding the sides and finding the angles. And so this is really what the whole of grade 10 trigonometry is about. And so once we've got this understanding solidly done, we're ready to go on to some more grade 11 type things. Give me a thumbs up if you feel comfortable with this work. Give me a thumbs down if you feel like, whoa, my grade 10 year was not great. I'm still feeling very confused about this. Thumbs up if you're feeling okay.
Yeah, I'm seeing a lot of thumbs up, so that's a good place to be, guys.
Okay, and even if you're not, don't stress, because remember, we've been creating content and videos for this for a while. It may just be that today you're joining us on a day where you haven't had a chance to start from the beginning. And what I would say is that you should go and have a look at the first 2 videos in the series before our next lesson, and then it will be a lot easier to follow along. So don't be discouraged. Obviously, if you're joining us in the 3rd lesson, you're going to feel a little bit lost. Okay, what I want to do is at the very beginning of today, I made a really big deal about working out the cos of 60. And so I actually showed you that, oh, sorry, my pen is jumping around. I showed you that you can take an equilateral triangle, cut it in half and get this, and you can get that the cos of 60 is equal to a half. Okay, you can physically measure the sides, and I think we had a 1 here and we had a 2 there. Now, what's strange is if I take the cos of 60, let's say I write down the cos of 420, it's quite hard to imagine that. So I've been talking about how trigonometry is about triangles, how it's about right-angled triangles, and it's got to do with similar triangles. But if I go and say the cos of 420, I'm kind of blowing my definition out the water, because no triangle can have an angle of 420. So give me a thumbs up if you understand what I mean by that. Like, how my definition, how do I say the cos of 420 if cos is about triangles? Are you agreeing with me that that's a bit weird? Like, what the hell is going on there? Okay, but now this is what's interesting. Type into your calculator the cos of 420 and see what you get. So what I'm pointing out is that trigonometry is all about triangles and about angles in triangles. And yet, if I type into my calculator will take the cos of 420 and it'll give me a value. And the question is, what is my calculator doing with that? Because how do you make a triangle with 420 degrees in it? And so what I've asked you to do is just a little bit of fun. Put cos of 420, and everybody's saying the cos of 420 is equal to a half. And so what I want to do is I want to introduce you now to something called the cast diagram and the circular definition of trig functions. And I want to do that by saying, look, you know that this first triangle exists, but I want to take this triangle and I want to put it on the Cartesian plane that you guys know about. So if you think of a Cartesian plane, you all know the Cartesian plane is just looks like that. I want to take my triangle over here and I'm going to put it on this Cartesian plane. So I'm going to make this 60. This is 90, and this is going to be 30. And this is going to be 2, and this is going to be 1. And this, we don't know what we could work it out using Pythagoras. All right. Now, in trigonometry, what we can do is we can extend the definition. So imagine if I gave you the angle of 420. What the angle of 420 would be is it would be going from, so in trigonometry, we always measure from the positive x-axis. And if I'm going to show you what does an angle of 420 look like, it looks like this. It starts here and it goes around. So that's 180. Sorry that my circles are so weird. 270, 360, and now I'm back to where I started. And what happens if I keep going around? I'm going to get back to 420. And so the reason that the cos of 420 is the same as the cos of 60 is that it is exactly the same triangle that's formed, because I've just added 360 degrees to it. It's just gone the whole way around and made the same triangle. which is a bit of a weird idea, but it's what the cast diagram is all about. Give me a thumbs up if you basically understand that. Give me a thumbs down if that doesn't make any sense. So let me show you with a smaller angle possibly. So if I go and I say to you, I want to talk about the cos of, let's say the cos of 120. In order to visualize the cos of 120, what I want to say now is that you clearly need an angle of 120. And so what I'm going to do is I'm going to start here and I'm going to try and get an angle of 120. If I get to here, I'm up to 90. If I keep going to here, I'm going to say that that is 120. Now, if I try and make a triangle that goes back to the beginning, I'm not going to get a, oh, sorry, someone is trying to phone me. What's going on there? Can you see how it, if I name the quadrants, I'm going to name this quadrant 1, quadrant 2, quadrant 3, and quadrant 4. I can't make a triangle in quadrant number 1 because I've actually, my angle has gone out of quadrant number 1. Now what's going to happen is I'm going to say, well, if that was 120, I'm going to drop a straight line down to here. And I'm going to make a 90-degree angle. How big is this angle over here inside the triangle going to be? What's the size of that angle? Oh, sorry, guys. So this angle was 120 degrees. Now, what size is this angle over here going to be? Okay, can you all see that that's going to be 60? So what I want to point out from before is I could take my good old 60-degree triangle from here, which had, I think it was 2, 1, and whatever that was, and I could actually put it in this quadrant over here using the angle of 120 to start with. But the cos of 120 is still related to a triangle which has a 60-degree inside of it. I'm not sure if I'm explaining it perfectly, but that's the basic idea. Now, I want you to type in your calculator what you get for the cos of 120. Type in your calculator the cos of 120. And what do you get? Can you see you no longer get 0.5? You now get negative 0.5. So why are you suddenly getting a negative is what I want to ask you. And this is what I'm going to explain to you in a moment. If you look at the position of where things are, in quadrant 1, we will say, let me just change my color. In quadrant number 1, we say that the R is positive, this is positive, and that's positive. But in quadrant number 2, we see that the X is negative and that the Y is positive, and this will stay positive. And so the reason we're getting a negative in this quadrant is that if you were going to work out cos, what two sides would be involved? If you think of this triangle, you're going to get, and I'm going to go over this, guys, so if you're feeling a bit lost, don't stress. Do you agree that this is the A side and that is the H side? Because this is a 1 and that's a 2, we're still going to get a half, but because the 1 is now negative, that's why we're getting a negative a half. And so that's why we can have angles that are greater than 90, because we can just push them into another quadrant, and then in that quadrant, we just make a right angle to start with. Now, I still think a lot of you are a bit confused on this, and so I want to give you one more example of this again, and then I'm going to go from there. Okay, so if you imagine, let's do the cos of 240. Now, if I want to work out what that value is on my calculator, I can work it out. But let's try and visualize how would we construct a triangle for the cos of 240. So 240, I go past quadrant 1, I go past quadrant 2, and now I go into quadrant number 3. And I'm going to draw a triangle now that relates to that. This is going to be a right angle. How big is this angle over here going to be? Okay, because you got 90, 180, this is going to be, oh, this is going to be, keeps on going. This is going to be 60 degrees. And so now, do you think the cos of 240, I want you to predict this. Is the cos of 240 going to be, I think we all know that it's going to be a half of some type. Is it going to be positive a half or negative a half? I want you to predict this.
Negative.
Okay, why is it going to be negative? Because you deal with cos, you're going to deal with this one over here, and this is negative because it's on the negative x-axis, and this one over here is going to be positive. Okay, so that's why it's negative. Let's do one more. Let's think of the cos of 300. So if we think of the cos of 300, let's try and visualize that. Guys, I'm going to give you a break in a second. I just want to bring this together. How would I visualize 300? I go 90, 270, sorry, 180, 270, and now I'm going to get to here. Notice how I'm making my triangle with the, can you see how I always make my right angle with the horizontal axis? How big is this angle over here going to be? Okay, it's going to be 60. I'm going to use the same length of sides that I had before, but is the cos of 300 going to be positive or negative? And why is it going to be positive or negative?
Positive.
Well, if you look at my right angle triangle, in terms of this, can you see that the 1 is now in the positive x-axis? And we know that in this, that the 2 is always going to be positive. And so we have that. All right. What I wanted to show you is how we can work with angles that are greater than 90 and still have triangles and trig ratios. I want you to write this down in your book. When we do this process, because we're going to practice this for the rest of the lesson, whenever we use the reduction formula, angles in quadrant 1 are always going to be of the form of x or some number. If you're in quadrant number 2, then it's going to be 180 minus x. If you're in quadrant 3, it's going to be 180 plus x. And if you're in quadrant number 4, it's always going to be 360 minus x when you're reducing things. And I'll show you what I mean in a moment. But for now, that is the main idea, that when you're reducing, for example, when I had the angle of 120, which was in quadrant 2, I went 180 minus 120 to get my 60. Okay, I've probably done a little bit too much talking around this to start with, and it's time for us to really do some questions, which kind of, what I was trying to do is show you how I build the triangle. But let's go to a question to show you kind of what a typical question would look like. And then I'm going to give you a break. So if I look at this question is the sine of, it tells me the sine of 40 is equal to that. What is the value of the sine of 140? And so what we need to do is we need to think about how can we reduce the sine of 140 to be in terms of 40. So we ask ourselves, where does 140 go to? It ends up in quadrant number 2. So that's 140 degrees. And what I refer to is, I refer to this as the generating angle. It generates my triangle. Then what I'm going to do is I'm going to say, well, what is the reference angle in the triangle over here? And the reference angle in the triangle is going to be 40 degrees. Okay, now, the thing that I haven't told you about yet is something called the cast diagram. If we put the letters in for the cast diagram, we know that sine will always be positive in quadrant 2. Wherever there's an S, where basically the A stands for all trig ratios will be positive here. The S stands for sine is positive, all the other ones are negative. The T stands for tan is positive here, and all the other ones are negative. And the C stands for cos is positive here, all of the other ones are negative. So what this allows me to do is to say this. We know that the sine of 140 is actually the same as positive the sine of 40. Because sine is positive in this quadrant, and we know that the sine of 140 actually reduces to a triangle with 40 degrees in it. So how would we now answer that question? Well, if we know that the sine of 40 is 0.6428, then the sine of 140 will also just be positive 0.6428. It'll be exactly the same, and the answer will be D. Okay. Let us do, guys, can you give me, I've spoken for quite a lot because I've tried to explain a lot. Give me a thumbs up if it's making sense. Give me a thumbs down if it's not making sense at all. I just want to get a feel for the group. Coco, is there anything? I was talking for a lot tonight, but anything from the group?
I think everyone's quite with you, Mr. S, at the moment,
Okay.
so it's looking good.
Okay, now, can you try and do question 2, and then we are due a break. So question number 2, I want you to make a triangle that relates to this 325 and see what quadrant are you in. And then I want you to try and reduce this using what I call the reduction formula and see what we get. I see there are quite a few students who are not quite there yet. And so guys, we are going to just slow down now and make sure that you get it. But I want you to first start by doing a little drawing and ask yourself, what triangle will go with the tan of 325? And then what I want you to do is I want you to use this Okay, so we're definitely going to be in the 4th quadrant for the tan of 325. And the tan of 325 has to end up being negative. Because in quadrant 4, only cos is positive. So we know that there's going to be a negative there. Now the question is, what is the little angle that is sitting inside the triangle? Or another way teachers would say it is they'd say, how far is 325 from the nearest horizontal? Okay, so it's 35 degrees, and we're still going to write it as a tan ratio. It's going to be minus the tan of 35. So what have we got here? We've got the value for the tan of 35. And so what we should have then is we should get minus 0.7002, which is going to be A. So guys, I'm going to start to teach you more formulas to do this, but I really wanted to make a point about showing you that 325 can't really be a triangle. 325 gives you an angle and what I call a generating angle, and that generating angle gives you a reference angle. And the easiest way to work out that reference angle is to say, how far is it from the nearest horizontal? Okay, I think it's time for a quick break. So let us all get away from our chairs for a second and stand up, because I think we all need a break. And what we're going to do today is I think we're going to do pen flipping. Pen flipping. Okay, so what you need is you need a pen, and you need, basically, you hold it from one side. And what you're going to try and do is with your non-dominant hand. So not your right hand, if you're right-handed, the opposite hand. You're going to try and toss it in the air, and you're going to try and catch it on the same end that you toss it. And you're going to try and get it to spin once in the air. So you do this. Oh, didn't get it right. So, okay, you couldn't see it on camera, but I managed to get it. There we go. See if you can catch it. There we go. It takes quite a bit of control, but your brain will leave the maths far behind. Oh, I think I get overconfident and cocky, and then I can't do it anymore. Ah. Okay, I want to see who can do this. Turn your cameras on. Show me what you got. And Coco, while I'm being amazed by our students who are winning at life, is there anything I need to be aware of for going forward? What was the general understanding level? Are most people with us at this stage?
I think most are. I think I've seen about four hands that gave us a thumbs down. And if you did give us a thumbs down, guys, can I please just ask you to private message me in the chat so I can kind of get where you are?
Totally.
Okay.
Yeah. All right. If you're feeling a bit more relaxed after the brain break, give us a thumbs up. And if you were like, this brain break thing, it don't do nothing for me, give us a thumbs down. I just want to get a feel for I always find it helps me. So I'd love to get a sense of kind of how you're finding it. Okay. So let's really get into the meat of this reduction formula. Now, I've showed you the thinking behind it, but in reality, it's a process that you can follow. And what you're doing is, to give you a few more words behind this, you're given a certain trig expression. You're given that the sine of 76.2 is equal to 0.9711. And all of a sudden, they want you to use that to find the value of this. And the key idea that you need to realize is that these two are related. The way you'll spot that is you'll spot it by realizing that what quadrant am I in? Now, quadrant 256.2 is actually going to end up being in quadrant 3. And so instead of doing a whole fancy circle to show you, I'm just going to say to you, what is the reference angle going to be that you get by drawing a triangle in quadrant 3? And what you can do is you can say, well, how far away is 256.2 from the nearest horizontal? And you just get 256.2 minus 180, and you get 76.2. And that's good news because we knew that from before. But the question of if we use the reduction formula comes down to the cast diagram. And so in quadrant 3, sine is negative. And so when we reduce the sine of 256.2, when we reduce it, it's still going to have to end up being negative. But it's going to be negative sine of 76.2. Now, how can you use that to help me get the answer? I want to see in the chat, what answer are you going to get? So you know what the value of sine of 76.2 is, but you're looking for the value of sine 256.2. Yeah, it's A. Perfect. Okay, this one you're going to do all by yourself now. And so what I want to do is I want to leave that to you to see if you can do it. Give you a bit of time. So normally we start by saying, what quadrant are we in? I need to reduce the big angle, 250. I think I'm in quadrant 3. Now, how do I know if cos of 250 is positive or negative? I suppose I could use my calculator, or I could use what we call the cast diagram. Give you a little bit more time. So the cos of 250 can be reduced. It's going to have to be a negative because it's in quadrant 3. It's going to be negative the cos of 70. I know what 70 is. It's 0.3420, but it's a negative. So the answer is going to be B. Because I take the 0.3420 and I put it there, but then I also have to include the negative in front, which is why I get my answer like this. Okay, next question. Where is 290? I think I'm in quadrant number 4. What's this red dot going to be? And remember earlier in the lesson, I said all reference angles in quadrant 4 are going to be of the form 360 minus x, whatever the angle is. So you'll go 360 minus 290.2, and I get 69.8. So this is going to be 69.8. In quadrant 4, cos is positive. When I reduce it, the cos of 290.2 is equal to positive cos 69.8. And that's what we call using the reduction formula. And so we should then find that the cos of 290.2 is exactly the same as the cos of 69.8, which means it should be C. Okay, so we seem to be going nicely there. Let's change the type of question now. I want to use this type of question uses something, it says without using a calculator. But what I am going to give you is I'm going to give you what we call special triangles to help you. So there's 2 important special triangles that whenever we see the question, you may not use a calculator. Earlier in the lesson, I gave you one. So the one is 2, 1, root 3. And then the other special triangle, and this is going to be, what is it, 2, 1, this was 60, and that was 30. And then over here, this should be 45, 45, and this should be root 2. Let me do the first one with you, and then you can do the second one by yourself, I think. That would be the easier. Actually, no, maybe let me have a go at this. See what you can do. Can you use those triangles and then try and reduce the 2 angles that are bigger than 90, and then use the drawing to work out values for those? I think I've given enough in the lesson to help you with that. However, if you're uncertain, I'd love for you to come on the mic or to message, and we can have a discussion. Remember, you can't use a calculator with this one. So that's the key thing. You have to use the triangles above. Okay, Muzi, I'll have a look now. I want us to first concentrate on working out what the tan of 150 should be. So if I was reducing the tan of 150, what quadrant would I be in? I think I would be in quadrant number 2. And so if I was in quadrant number 2, would I be positive or negative? I think the tan is negative in that quadrant. And then the question is, what is this angle over here? How far is 150 from the horizontal? And so you should get minus tan 30. And the sine of 30, you do not need to change because it's already an acute angle. But now we still need to work on the cos of 210. So this is what we've got so far, but I'm waiting for something to fill in the cos of 210. Now, what quadrant is 210 going to be in? Well, I think it's just going to be in quadrant 3. And so let me draw this in. I think it's going to be another negative because it's negative in this quadrant. And then it's going to be the cos. Now, what's this angle? It was 210. So it must be the cos of 30. So how do we get our final answer? So we've got minus the tan of 30 times the sine of 30. Now, minus a minus is a plus, which is plus the cos of 30. Okay, so now the last step is to use substitution. I'm just going to zoom in so I can see my special triangles. How do I get a value for the tan of 30 using my special triangles above? Which triangle has a 30 in it? I think here's my 30 over here. And so what would, if I have to try and work out what the tan of 30 is, the tan of something, so we can go, the tan is over A, so it's going to be minus 1, so O over A, which is root 3, and that root 3 comes from this. And then what do I get for the sine of 30? Well, the sine of 30 is going to be O over H, so it's going to be a half. And then the cos of 30 is going to be root 3 over 2.
So I think we're subtracting rather than adding.
Oh, we got minus a minus. So if
minus
we go
3 over 2. Yes.
No, be careful. So if you look back here, can you see there's minus a minus? So when we took the cos of 210, it became minus a minus there. Would you agree with me?
And then it gave us positive.
Yeah.
Okay.
Yeah. So
Understood.
that's a bit of a tricky one. But I think, yeah, I would expect a lot of you to still feel a bit unsure about that. But if you feel like you could follow what I was saying, give a thumbs up. If you're feeling very lost and a bit discouraged, give a thumbs down. So what I was trying to show you, this is where you've used the reduction formula to simplify trig ratios from obtuse angles. So notice how tan of 150 is greater than 90, 210 is greater than 90, and I'm reducing them to acute angles. And then I'm using my actual physical triangles to get values instead of using my calculator. Okay, let's do one more. I probably have, this is a little bit easier. So in this case, they don't give you a number, they give you a variable, but theta is always going to be less than 90. So to show you how you represent 180 plus theta, 180 plus theta is just going to be in that quadrant here. And so this value over here is going to be theta. So can you try and simplify this question by working separately on each of these. And then I think we may call it a day for today. We will definitely do another lesson on this. We're not done with this. This is just that. Coco, we're going to run that poll. In fact, I think maybe we run that poll right now. So we want to, while you're doing this last question of the day, we want to run a little poll just to get a feel for how you guys feel about the pacing. And if it's, yeah, it'll help us. So I'm happy for you to release the poll, Coco.
Okay, thank you guys. Something's going to pop up on your screens just now. There are 3 options. You just need to pick whichever option you're most comfortable with. All right.
And then we'll work on these 3. So let's try and do this. Okay. That's useful. I can see, yeah, we can see keep voting, guys. It's helpful to see that.
5 more votes. 4 more votes.
Get those votes in. All right. Okay, let's finish off this lesson with this one, and then we'll go from there. And in the next lesson, guys, for about 1/3 of the class does think we're going a little bit fast. About 2/3 thinks the pace is right. We obviously are going to get a mixture, but I know that this topic takes a bit of time to get used to. So don't be afraid. Like the next lesson, we're going to practice this some more. But just to finish off with this last question, if you want to visualize, I've already solved the first one in green, but the cos of 180 minus theta, what quadrant is that in? Well, 180 minus theta is going to be this angle over here. It goes to here and back. And so we ask ourselves, basically, it's going to be theta away from the nearest horizontal. In that quadrant, cos is negative. We're going to get negative cos theta. And then the last one, sine of 180 minus theta is going to be, what quadrant is that in? 180 minus theta is in quadrant 2. And so sine is positive in quadrant 2. And so we're going to get a positive, and it's going to be sine of theta. Now, we haven't covered the identities yet. And so at this stage, I'm just going to leave that question at that point. Okay. And then in the next lesson, I'm going to go over these ideas again. Today was just trying to show you how we could go from acute angles, which are valid in triangles, and we could extend the definition of trig to angles that are huge, like 420, 540. And what I want to leave you with is basically we take those big angles and we make triangles again in specific quadrants. If they're in particular quadrants, they can be positive or negative, but the value itself won't change because it's the same triangle. It's just which quadrant it's in makes it either positive or negative. And so that's why at the very beginning of the lesson, we had a positive half for cos when it was 60, but a negative half for cos 120. But I hope that we kind of got you going. And Coco, anything from you before we finish?
No, I think that's it from our side. But thank you so much, guys, for joining. Remember to practice. I know that a lot of you will be doing this at school at the moment, and we're really not going to be able to cover everything in 1 hour. So it is up to you guys to go and practice as much as you can until you kind of get the concepts. Even if you want to come back on Thursday with a couple of questions for us about what you've been studying and what you've been practicing, I think that'll help you guys a lot more. But yeah, thank you so much for joining us, guys. Ronewa, I'm so glad you enjoyed the lesson. That was awesome. Thanks, guys.
Thanks, guys. I will see you all on Wednesday. And if you feel a little bit overwhelmed today, just hang in there. Trust me. Like, you just need a bit more practice. You will get there eventually. Okay, we're going to end the lesson, and I will see you on Wednesday. Ciao, everyone.
Thank you.
Ciao.
Bye, everyone.
Thank you.
Bye.
Ciao, ciao.
Bye, guys.
Bye, guys.